Example 4, the lotus seed. If we choose to show the year it sprouted as an estimate, and by the way, do we know how old these thingamajabbers were? Do they tell us in the story problem? What do they tell us? Hope. We're going to continue to use that estimate. Does that sound good? The question is, what's the age? Do we know the age? No, that's why we're trying to solve this thing, right? How's that look? Do we have an equation that represents this scenario now? We do. The year it was formed, that should be a Y. I just want it to be a Y for myself. The year it was formed, the variable, they used X. I'm using Y because it reminds me of the word year. Plus 500 years gives us the year in which it sprouted. How can we figure out what the value of Y is? What do you think, Ryan? How can we figure it out? Don't tell me the answer just yet. Nope, Emma. Subtract 500. Yep. You're going to subtract 500. So now on the left, all I have is the variable Y, which is the year the seed was formed. And now on the right, I have that year. The year was 1500, 8 years after Columbus landed in, yes. Yep, because we subtracted 500. Yep. Yep. We subtracted 500. So 2,000 minus 500 is 1,500. So that is a decent estimate for when these seeds were formed. Okay, remember, they're about 500 years old. This happened over the span of 98 to 2002. Okay? Here's another example. This is checkpoint 8. Look at it at the bottom of the page. This is checkpoint 8. Bottom of page 86. It's go-kart rides. Go-kart rides cost $5 each. So $5, $5, $5, $5. We're all riding go-karts, $5, $5. You get it? I'm just kind of $5 per person, $5 per ticket. During the first day of the fair, the rider took in $1,000. How many times did people ride the go-karts? How many times did people ride the go-karts? Some of you might already know it, but how would we set up an equation to represent that problem? Emma, give me an idea. Give me an equation with a variable. Yep.
So like A times $5 equals $5.
Yep. And if you decide you want to do R for ride, it's fine. Who cares? She picked A. So $5 per ride times the amount of rides that were paid for is the $1,000 that the go-kart riders earned on that day. 5 times some number of tickets, or whatever they used, gave us $1,000. How can we find out what that factor is being multiplied by the 5, Rachel? Bravo. We're going to divide by 5. So we now have the amount of rides equivalent to this quotient, which looks like it's going to be 200 rides, or 200 people. Okay? So we did an addition-subtraction scenario up here with the 500-year-old lotus flower. What on earth would a 500-year-old seed look like? I mean, I just can't imagine. We did a go-kart ride. We have this many, or this much per ticket. I earned this much money. Appetizers. Appetizers. Read the appetizer story real quick while I turn the page. Don't read 1, 2, 3, or 4 within the appetizer story. Just read the story. Just read the story. It's a lot less complex than you think. So I'm making quesadillas for my folks, for my people. There's going to be 12 people at the party. Each quesadilla is going to be cut into 4 wedges. Okay? This is the quesadilla, and it is cut into 4 wedges. Right? 4 wedges. You anticipate that each person will eat 3 wedges. 12 people, each person will eat 3 wedges. So the question in the end is, how many quesadillas do you need to make in order to make this happen? First question, we are going to go through and answer it one question at a time. Let X represent the number of quesadillas you will need. Well, if each quesadilla is X and I get 4 wedges per quesadilla, then I would say 4 times X is the appropriate representer for the quesadilla scenario. If you're not copying this, you're really going to have an issue later, and you're going to leave me a lot of question marks. Write an expression for the number of wedges in this quantity of quesadillas. So if I make 1 quesadilla, how many wedges do I have? 4. If I make 2 quesadillas, how many wedges? 8. So X equals the number of quesadillas. All right, we know that because they told us that. How many wedges do you need based on the story problem, based on your estimate, to feed those people? And how can you find out that information? Eli, go. How many wedges, right? 3 per person. How many people are there? What's the total number of wedges you need for all 12 of them? Bravo. So he said, well, I have 12 people, and they're going to eat 3 each, which means 36 wedges is the total I expect for my quesadilla eaters. Sorry, that's not enough for me. I need like 12 wedges. That's question 2. The third, use your answers from step 1 and 2 to write an equation that you can use to find the number of quesadillas you will need. So if I know 4 times this, and if this represents the quesadilla count, and I need to get up to 36 quesadillas somehow, then I would say that 4 wedges per quesadilla somehow has to equal 36. Would 1 quesadilla work? 4 times 1? Because it won't equal 36, right? I know some of you already have the answer, and that's super. How many quesadillas do you think I must make, and why, Miss Grace?
9.
She's right. The answer is 9. So you need 9 quesadillas in order to satisfy what you think is going to be the appropriate quantity of quesadillas. She better be serving some nachos or something else. That ain't enough food. Okay. I'm going to talk to you guys a little bit about number 36 for just a quick second. Real quick. Scientists often use the Kelvin scale to measure temperature, okay? Don't get bound up in this. Just follow along with what they're telling you. The temperature in kelvins is related to the temperature in Celsius in this way. Kelvins is equal to whatever the Celsius temperature is plus 273, okay? So for example, today it is, how many Celsius you think, Ikyan? 25 Celsius today? 25 maybe, good? Okay, 25. So just for thought, if I wanted to know how many Kelvin today is, which I don't, I would take my Celsius number and add 273 to it, okay? I have this number, we've decided that's gonna be our number. So I could say today it equals 298 Kelvin, okay? The Kelvin scale is useful for very, 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 very cold things, and I'll leave it at that. Based on what I have just shared with you, part A says, explain in words how to find Kelvin temperature based on a given Celsius temperature. If you're given a Celsius temperature, what must you do to it to get Kelvin? Grace.
You take that Celsius temperature and you add 293.
Yep. Add Celsius temp plus the 273. That is a static number. Whatever your Celsius is, you add 273. Okay? The lowest possible temperature a substance can have in Kelvin, lost my place, is 0. That's called absolute 0. What is absolute 0 in degrees Celsius? Some of you might already see it, some of you might not. So if I tell you 0 is Kelvin, okay, they just said the lowest temperature in Kelvin is 0. How can I solve for Celsius? What can I do? Rach, go.
Subtracts 273.
She's right. So that means the Celsius value for absolute 0 is negative 273. Negative 273. Letter C. The table below shows melting points of a variety of stuff. Convert it to Celsius. Convert it to Celsius. Kelvin, Celsius. Okay. They give us 63, 172, 303, and 973. Which one you guys want to do? Nitrogen, chlorine, gallium, or radium? Or any other Grace, pick. Nitrogen. So they've given me my Kelvin temperature. Where within the above equation will I plug that in? Since they gave me Kelvin, Mason, where will I plug in that Kelvin temperature into the above conversion? Since this is Kelvin, will I plug it in for Kelvin or will I plug it in for Celsius? Since this is Kelvin. Since this is Kelvin, and the problem asks us to convert all of these to Celsius, using the following equation up here. If we know Kelvin, we can solve for Celsius. Where will I plug this value in order to solve for Celsius? This is Kelvin, K, Kelvin. Where do you think you'll put this? Where do you think you'll put it? Do you think you'll plug in the K value for K? Or do you think you'll plug in the K value for Celsius? Since we're solving for Celsius and we don't know Celsius. This is not C though, this is K. So since it's K, where should it go? Good. Just like the one we just did. Did you copy this one? Yep, same exact thing. So I'm going to do this one with you. I'm just going to do it off to the side. 63 is equal to C plus 273. Remember, we're solving for this. We don't know this. We can subtract. Did y'all come up with a negative 210?
Yeah.
Negative 210. I'm reasonably certain that you can perform this basic arithmetic for the remaining of your assignment. Lastly, letter D, interpret and apply. I have practically given you this information in an answer. So, you better answer that question. I don't want to see blanks. I've practically done this whole thing with you. I'll let you guys go ahead and have